In this section, we want to use our properties of exponents to simplify some expressions. Here's our first problem. I have x to the fifth times x to the fourth. It's multiplication with the same base, so I know from my properties of exponents that I need to add exponents, 5 plus 4. And so I have my same base x raised to the ninth power. So that's our first property of exponents that tells us that when we multiply with the same base, we always add exponents. Here's our next problem. Here I have 2 to the third, and that whole quantity is raised to the second. So I have a power raised to a power. In this case, I'm going to multiply exponents. So it'll be 2, that's that base, raised to the 3 times 2. That's the product of those two exponents. And so I have 2 to the 3 times 2 is 6. So that'll be 2 to the 6th power. Now I can simplify that even further by just multiplying 2 times 2 times 2 times 2 times 2 6 times and simplify that a little further. I won't do that. Let's go on and work the next problem. I have negative 3a squared times the quantity 2a to the fourth. So I want to use my properties of exponents and also my commutative and associative properties. So I'm going to start by regrouping and writing this as negative 3 times 2. So I'll group the coefficients together, and then I'll group the numbers with exponent, or the variables with exponents together. A to the fourth times a to the second. So that's the commutative and associative properties. Since it's all multiplication, I can rearrange the order and I can rearrange the grouping. Now I'll just simplify. Negative 3 times 2 is negative 6. A to the second times a to the fourth, it's multiplication with the same base, so I add exponents and I get a to the 2 plus 4, which is 6. So there's my answer to that problem, negative 6, a to the 6th power. Here's our next problem. Here I have a negative exponent, 3 to the negative 2nd power. I know from my definition of negative exponents that this is defined to be 1 over 3 to the positive 2. So negative exponents always indicate reciprocals like this. Now I'll simplify 3 to the 2nd power. That's going to be 1/9. So with negative exponents, I always get reciprocals. I don't necessarily get negative numbers unless possibly my base is negative and I have the right kind of exponent right here. Here's our next problem. 3y to the fifth, all that to the negative 2, and then I have 2y to the negative fourth, all to the third. So I'm going to start with my property of exponents that says that when this is multiplication and everything's raised to a power, I can distribute that power over both things in the product. So I'm going to start by writing this as 3 to the negative 2 times y to the fifth, all raised to the negative 2. I have a power raised to a power, so I multiply exponents. Y to the negative 10th. Here I have 2 raised to the third power, so 2 to the third. And then I have y to the negative fourth raised to the third, so I have a power raised to a power. Again, I multiply exponents, and I get y to the negative 12th. This is equal to 1 over 3 to the second, which is 1/9. Y to the negative 10th is 1 over y to the positive 10. 2 to the third is 8. Y to the negative 12th is 1 over y to the positive 12. Now, I'm running out of room right here, so I'm going to bring this back over here and write this as 8 in the numerator over 9 y to the 10th times y to the 12th, which should be 9 y to the 10 plus 12 is 22. So I have 8 divided by 9 y to the 22. So that's a little more complicated expression. We had to use more than one of our properties of exponents for that. I want to do another problem like this also that involves division. Here it is. Here I have 6 to the second power. That's going to be 36. I have x to the negative 3 to the 2, so a power raised to a power, and multiply exponents and get negative 6. Y to the negative 5th to the second power. Again, I multiply exponents and I get y to the negative 10th. In the denominator, I have 3 to the fourth power. That's going to be 81. I have x to the negative 4 raised to the 4, so that's x to the negative 16. And then I have y to the negative 3 to the 4. That's going to be y to the negative 12. Now, I'm going to treat these as 3 separate fractions right here, and I can do that with my properties of fractions. So I'll treat the numbers separate from the variables that contain the variable x and separate from the variable y. So first of all, I notice that 36 and 81 have 9 in common, so I'll divide that factor of 9 that's common to those out, and I'll be left with 4/9. I have x to the negative 6th divided by x to the negative 16, so I'll subtract exponents. Negative 6 subtract negative 16 is going to be negative 6 plus 16, which is going to be x to the positive 10th power. Now, my y variables, I have y to the negative 10th divided by y to the negative 12th. So I'll subtract exponents. Negative 10 subtract negative 12 will be negative 10 plus 12, which will be 2. Now I can simplify this a little further by just writing 4 x to the 10th, y to the 2nd, all divided by 9. So here I've used my properties of exponents a couple of different ways right here and simplified this expression down to where I just have numbers, the variable x with an exponent and the variable y with an exponent. The next problem involves scientific notation. I want to write 378,000 in scientific notation. Scientific notation requires that we rewrite our number as the product of a number between 1 and 10 with a power of 10. So if I change this to a number between 1 and 10, I'm going to have to put the decimal point right here, 3.78. That's a number between 1 and 10. Now I have to multiply by a power of 10 to make up for what I've done here. I still want it to be 378,000. So I've moved this decimal point from where it was right here, 1, 2, 3, 4, 5 places. So if I multiply 3.78 by 10 to the 5th power, this number and this number will have exactly the same value, but this number is written in scientific notation, a number between 1 and 10 times the power of 10. Here's our next problem. Write 3.44 times 10 to the negative 3rd in expanded form. Well, this number right here is a small number because I have 3.44 times 1,000th. So I know when I expand this, it's going to still have to be a small number. So that tells me I'm going to have to move the decimal point from where it is 3 places this way to make sure I end up with a small number. So 0.00344. So that means I've taken the decimal point from here and moved it 1, 2, 3 places to the left, which is the same as multiplying this by 10 to the negative 3rd power. So a little introduction to our properties of exponents and a quick look at scientific notation.